Okay, section 14.1 is about radians versus degrees. So we've been doing degrees all throughout, and now we're doing radians. And what a radian is you take the radius of a circle, whatever length this is, say it's our unit circle, so it's length 1. If you lay that out so it's along the circumference of the circle, then that measure right there equals 1 radian. And so our conversion on this is 1 revolution, right, equals 360 degrees. So that's all the way around. 1 revolution equals, and then the circle is, circumference is 2 pi r. So if r is 1, the circumference is 2 pi. So that means there's 2 pi radian in 1 revolution, or 360 degrees. So the rest of these are just practicing converting back and forth and finding the radian button on the calculator. So it's a pretty friendly one after the law of sines and cosines. So for this is number 2, so we're back to out of the book. Number 2 is 18.7 degrees. We're supposed to put that in radians. So what we do is we just take our degrees. And the way I write it is like this. I just think of it as this is a division bar and this is a multiply. So I need degrees to cancel, so I put 360 degrees down here. I'm trying to get into radians, so 2 pi radian, and then degrees cancel, my units left are radians. And so if we do that in a calculator, you'll get 0.326 radian. Number 6 was the next one. This is revolutions, 1.27 revolutions, and we're trying to get into radian. So again, I'll just do this, and so 1 revolution equals 2 pi radian, so revolutions cancel, and I'm left in radian. And if you do that out, it'll be 7.980 radian. And number 8, we'll do that one over here. Let's see, so we have 2.30 radian, and we're trying to get into revolutions. So here, we want radian on the bottom, revolutions on top. So notice I'm just following the units, because I know radian have to cancel. So 1 revolution is 2 pi radian, and I'm just using my conversion factor. And then after that, toss in the calculator and get 0.366 revolutions. Would be the same thing as 2.3 radian. This is number 14. We have 4.275 radian, and we want to get to degrees. So radian on the bottom, degrees on top. 360 degrees is 2 pi radian. And so those cancel. I'm left in the right units. And again, it just goes into a calculator, and we get 244.9 degrees. Number 20 is 130 degrees. We want that to be in radian. So 360 degrees on the bottom, 2 pi radian on top. Again, units cancel. And that in the calculator yields, actually that one I did the exact form. And I think it's because it has an exact form as pi. So I canceled the zeros, and then this I could reduce 1 and then make that an 18. So 13 pi over 18. Let's see, 32 is 2/3 pi. Ooh, you know, I did not write down what I was doing here. I think it was just 2/3 pi. Oh, it was just 2/3 pi, which is radian. Sorry, I wrote it a little bit different in the notes. So we're given 2/3 pi radian, but the deal was, because it was a fraction, I didn't want to do the division bar and then have a complex fraction. So I'm just multiplying that by 360 degrees and then radian on the bottom, 2 pi. And then the 2 pi cancel. And then 3 goes into 360 120 times. So that would be 120 degrees. And then 44 and I think it's 65. Can't quite read my writing. These are just finding the radian mode on your calculator. So if you do tangent of 0.442 and you're in radians, you should get 0.473. And so it's usually under mode. If you look on the back of your calculator, look up the model. It's some fairly easy thing to switch back and forth. And then 65 was arctan of 3.7253. And so that's, remember, the same thing as the inverse button. Usually they show it as this. And if that gets in the calculator right, it should be 1.309.